Let's shift gears then and talk about what's called the 10x theory. It was actually Dr. Deming that came up with the idea of each stage of the manufacturing process, it costs 10 times more to find a fault as you go through a manufacturing process. So if you run your numbers and actually do a calculation, you'll see that these numbers are pretty accurate, although it does vary from board to board, application to application. So sometimes it's only 5x, sometimes it's 20x. But let's just assume for the moment that the generic formula of the 10x theory holds, and the 10x theory is just saying that if it costs X to find a fault at ICT, it would cost 10 times that, 10x, to find the same fault at functional test. And if I had to find the fault at unit test, it would cost 100 times as much. So I can't tell you how many times I've gone into a factory to help somebody with functional test or in-circuit test, and they say, oh, we don't worry about catching those kind of faults at ICT because functional catches it. It costs 10 times more. The whole idea in the test engineering world is to push that back. Just keep pushing back these kind of faults and find them as early in the process as you can. As you do that, you're saving your company money. Obviously, if I can eliminate a fault from happening all by doing corrective actions, woohoo, now I'm really saving my company some money. But if it's a fault I've got to catch, then AOI during the process, AXI during the process, or a flying probe test for prototypes is an excellent way to make sure that we're pushing these faults back and find them early in the process when it's easy to test these boards. So another example of the idea of testing a board when it's half built, when it's going through the manufacturing process, is when I don't have parts loaded on both sides, sometimes I can test all kinds of devices that I can't test when the board is fully loaded. And capacitors are an obvious example. If all my surface mount caps are on the bottom of the board and I build the bottom first, then when my pin-fill hole devices like the polarized capacitors are loaded, well, they're in parallel with all those little caps. I can test these little caps that way. So these are just more and more techniques to try to push those faults back and find them early in the process. And you'll find that as you do that, you're saving your company money. So the idea then is to try to find these defects early in the process. Let's try to find these faults at ICT so that I can save my company money. But you know, if I could find this at the board level or the component level, then it's going to be 1/10 of X, wouldn't it? So I'm really going to save my company money if I can find that some of my raw cards coming in with some kind of defect, maybe a shipping defect, some other kind of handling defect, components, all kind of faults can occur on components, heat-related issues during shipping or vibration. So to find those kind of faults and get those out of your system is what's so important.